Okay, we're gonna do 1.3 and 1.4 today. These are both short sections. So we'll probably get done a little bit early, just because I only. Going forward, we'll use more of our time, but I'm just trying to pace with what the online thingy says. So let's hit it. Please stop me if you have questions. Okay, so 1.3 deals with sampling. So last time we said, okay, we have a population, which is everybody we're studying. And then we also have our sample, which is a smaller group from that population. So the big question is, how do you find your sample? There's good ways to do it, and there's bad ways to do it. So your population size equals a big N. So everybody in your group, we call that the size of that big N. Your sample size if you can guess what this is, I called that one big N because this one's going to be little n. So we do that a lot, use a capital letter and a lowercase of the same letter when things are related. And these are. So that's, big N, little n. In our class, when we do any of our calculations, we're usually going to use little n because it makes more sense. A simple random, oof, that looked good. Our goal is usually a simple random sample. That is not necessarily the easiest to get, but it's the best one in my opinion. So this is sample is chosen. In a way that such that each population has equal probability chance of being selected. So if we have whatever our population is, what is a good population? How about all of the students at DMAC who take statistics? Hoping to reuse these videos, so I'm not going to say what semester, just this semester. So that is our population. I have no idea how many there are because we have online students, evening, all of our campuses, I think, have this. We have lots. So that is our population. And I only choose students who are in morning classes to be in my sample. Does everyone in our sample have an equal chance, excuse me, in our population have an equal chance of being selected? No, No, because we have students who work during the day and they can only take evening classes. So if we're only choosing from the morning, we're gonna miss a huge portion of our population. So they don't have the probability of being selected. Or our online students, if they're not here in the mornings, we can't select them either. So if we only choose morning students, is it two O's? Select. For our sample. The evening and online students do not have a probability of being so in this case, we do not have a simple random sample since not everybody has the same likelihood of being selected. We have people who can never be selected. So we should take proportionally from each category of students, however we write that. So how do we give a simple random sample? Well, one way is to essentially throw, let's say we're dealing with people, because it's easier to say, throw all of the names in a hat and choose X amount of names. So whatever your N students you want to choose, you pull them out. That's a way to do it. So in a hat. Get simple random sample. We probably, oh God, that's terrible looking. We probably won't throw them in an actual hat. We'll probably have a computer online system that says, hey, randomly select this number of students, and they'll populate that for us. Order the population. And choose every case. So order them in some way, or you could just randomly order them. It really doesn't matter. Student ID is a good way to order people, or alphabetically by first or last name. Just order them, whatever. And you're going to choose every case. So maybe we want to choose every 10th person or every 50th person. And then that way we'll get a wide sample of different types, most likely. Usually they're not, your population isn't grouped too bad like that. Whoops, that's from the next section. I went ahead. Okay. So for our people, most of the time we're going to do something with no replacement, but depending on what we're talking about, if we look at cards, for example, we need to talk about, are we having our sample with replacement or without replacement? So is everyone familiar with a standard 52 card deck? Have you played with cards before? Is anyone not familiar with that? Okay. So we have 52 cards in our deck, and say we want to choose 3 cards. If we choose them and lay them down, so card 1, card 2, card 3, and we're not replacing the cards in our deck, the probability of the next card being whatever changes each time. Because say we have we have 4 aces in a deck. The probability of our first card being an ace is really easy to figure out. 4 to 52. We'll talk more about probability later. The probability, if we leave that on the table, of our second card being an ace changes. It depends, was our first card one or not? So if our first card was an ace, the probability of this one being an ace is, there's 3 left out of 51. And we want that one, there's 2 left out of 50. So if we don't replace our items in the population, the probability changes of the next thing being selected. With replacement, the probability is always going to be the same. The thing to worry about here is if you select the same thing twice, you can't always have the same people in your population. And replace. So in this case, the probability our first card is an ace, 4 out of 52. Well, you pick that card up, shuffle them again. The probability our second card is also an ace is 4 out of 52 because our deck is the same. 4 out of 52. So the probability doesn't change in this case. For now, that's not going to matter to us a lot, but down the road it will. You know, do we have replacement? Do we not have replacement? It changes things. Okay. One point four is also a very short section, so we'll pretty much be done after this. So our sampling methods, how do we choose our sample? So I kind of gave this one away already, but so every case is selected. So say we want our sample to be of size n. How do we figure out what our K should be? Pretty straightforward. We take the population divided by our desired sample size, and that is our K. You will probably get a decimal or a number with a decimal here. Round up or round down as you feel appropriate. I would just round regular. I wouldn't do any fancy rounding. You might end up having to throw one of the things selected out, change your sample size a little bit, or add one in. Either way, this isn't, you can always go through of all the leftover people or things and then sample the kth one again. That's not a bad idea. So. Okay. How do I want to do this? Okay, this didn't work. You know what, pen? That's better. Okay, let's say our population has 12. This is a really small population, but whatever, it's all the same, it'll work. What do you think a good sample size for our population could be? 4, 5, 6? I think 6 is too many. 6 is half of it. Can we say 4? Does 4 sound good? Okay, so we want a sample of 4. What's our K? So we're going to choose every third person in our list. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So persons 3, 6, 9, and 12 are chosen for our sample. And then we get their opinion on something. Or we measure something about them depending on what we're looking at. Maybe we're looking at blood pressure, so we measure those people's blood pressure or their opinion on their favorite Starburst flavor. Also, you should always be friends with somebody who has the exact opposite Starburst preference as you, so then you can share one and everyone's happy. Just my life advice right there. My kid and I, we have the exact opposite flavors. We're a perfect match for that. Anyway, my life advice. So helpful. Okay. So that's a good sampling method. Again, throw things in the hat, pick them out, similar idea. What tends to happen is we get a convenience sample. Oh, yeah, because I have the eraser on. If I spell things wrong and you catch it, tell me, please. I am not always great at spelling. Okay, that's CO. I should just give a chiller. A convenient sample would be you pick whatever that's convenient for you. So if we go back to the example of all of the statistics students at DMACC, and I don't want to really work too hard for my sample, I'm going to pick like our class here. You would be in my convenient sample because you are easy to get to and I don't have to try real hard. Or if I have some friends in the department who also teach stats, I'm like, hey, I'm gonna come in your stats class and do a thing. Also convenient. So the subjects have made the samples for you. That's a bad idea. Don't choose a convenient sample. Because if you think about it, let's take our daytime students versus evening students. So I have a 6 to 9 p.m. class as well. Do you think the population of these two student groups are going to be different? I know they're different. My daytime students tend to be more traditional age, your 18 to 24-year-old. They probably don't have a full-time job. They may, but more often than not, they don't. And sometimes they live at home still with their parents, sometimes they don't. So that's typically what my daytime students look like. My evening students tend to be non-traditional, so they tend to be older. They do have full-time jobs. They're in the evening because they work all day, and then the only time they can be in school is the nighttime. A lot of them, if they're coming back to school, have kids, have a mortgage, things like that. So the opinions and what's important to these two groups of students is generally a lot different. Not about everything, but different enough that you should consider that. So if I chose a convenience sample of just my morning students and say, hey, this is how all of my stats students think, that is probably not true. So be careful of using a convenient sample for an important study. Or more often, when you read a study, did the people who did this use a convenient sample? If they did, their data is probably a little bit biased. Things to note. So another thing you can do, or ways we get a convenient sample, is to your sample self-selects. So your people in your sample just decided, maybe you're at a university where you've got all of these different studies on the board and you get paid $10 a study. That happens. Like, oh, this one on sleep sounds good. I'm going to do that study. Ooh, I get to eat candy in this one. I'm going to do that study. That is probably not a good way to get a sample of students because they're choosing if they want to be in there or not. You're not getting a good, I forget that cross something, not getting a good view of the population. You're getting a select view. Another thing, which is what I see all the time and it drives me bananas, is voluntary response. This is what happens on internet polls. So people still on Facebook these days, or are we all on something else? Okay, YouTube. YouTube I know has polls that you can take because my kid shows me them from time to time. He's very into YouTube. If you take a poll on YouTube or on any place, if you don't care about the subject, are you probably going to take that poll? No, that he shows me stuff for his various Pokemon whatevers. I'm like, oh, that's cool. I don't care. I'm not going to take a poll on my opinions on that. But if I have, I'm invested in this thing, I'm going to take it. And then I'm going to find my friends. They're going to take the poll too, and they're going to answer how I tell them to, because, we do that. So a voluntary response, you're not getting a good cross section. That was the word I was looking for of the population. You have people who care about it. Your news polls online will do the same thing. You only have people who, number one, watch that news site or read it online, or two, care one way or the other. So you get very polarized responses there. Not a good way. You shouldn't base your anything on those except for, oh, that's interesting, and go by. Your phone and text polls, I know a lot of political polling is having trouble doing their predictions nowadays because they used to do phone polls. Who answers phone calls where you don't know the number? Yeah, I don't either. I block them. So that's another voluntary response. You have to find the people and get them to respond. Text polls are the same way. I'm more likely to answer a text poll if I'm feeling it. If I'm not sure who's sending me this, I may not because I'm worried about their bias, which doesn't help things. So that's another way. Every election year, some random person leaves little papers with a QR code that you're supposed to scan in around DMACC. Don't scan those, it's bad. But that's another voluntary response. Then you're not going to get people who are, likely to be anybody. So you don't have a simple random sample there. Anytime you base your responses on these voluntary or your data on the voluntary response or the convenience sampling, you're not getting a good data set. You're getting a weird one at best. So, okay. That is the end of 1.4. 1.5 is scheduled for next week, and I didn't write notes on it. I have slide 83 and 1.5 bias is the only thing I wrote down. So we'll do that next time. We do not have class on Monday. So actually, let me stop my video. Sorry, people. Stop share.